form homogeneous mixture. Homogeneous mixture is a uniform mixture. It means that immiscibility, when you take these two substances and mix them together, then you will get immiscible or non-homogeneous mixture. Right? So that the meaning of the term immiscibility. We are still in the third topic of introduction of immiscible liquids that I'm trying to break down and simplify different concepts that you have to make sure that you understand before you go to other subtopics according to the requirements of the syllabus. So if you join with me right now, this is Sir Olenjolai, who is teaching you advanced chemistry and the topic of physical chemistry and another a topic known as state of matter. So again, now we've discussed a lot about miscible, immiscibility, and so forth. So another thing which we have to know, now we got the contents of the requirements, or the contents that we have to know, the second subtopic, and then we'll take it further. The second subtopic, we say that you have to know properties. The first subtopic there, but for this lecture, this is the second subtopic, properties of immiscible liquids. What are the properties of immiscible liquids? Now you know what the meanings of immiscible liquid. You know examples of immiscible liquids. You know the meanings of separating layer. You know the meanings of the word you know the reasons why one solvent is appearing at the top of the separating layer. And now I want to take you to the next level when we are going to learn about properties of immiscible liquids. So there are some properties. These are some properties which we call them physical properties or chemical properties. Some properties of the immiscible liquid. I found 4 properties, or yes, I found 4 to 5 properties. So you'll be looking for the other properties. So the first property we say that when the immiscible liquid boil, right? When the immiscible liquid boil, right? When the immiscible liquid boil below the temperature, when the immiscible liquids are boiling, or so the miscible liquids boil. Sorry, let me put this sentence. The first property of immiscible liquid, you say that the immiscible liquid, such as kerosene and water, right, boil below the boiling point. Below the boiling point of the pure solvent. The pure solvent. That's the first property. The second important property, we say that the vapor pressure, which I will explain it in detail after mentioning these properties, the vapor pressure, okay? The vapor pressure formed above the immiscible liquid is a sun liquid above the surface, means above the surface of the immiscible liquid, right? the liquid, above the immiscible solution. Above the immiscible solution is given as the sum of vapor pressure, of the pure solvent. Sum of vapor pressure of the pure solvent. Okay? When they are pure, of the pure solvents, of the separated component, the sum of the vapor pressure of the pure solvents. So each solvent has has a tendency of forming vapor pressure, as we learned in the previous lectures of ideal and non-ideal solution. So we say that the vapor pressure now, the vapor pressure of immiscible liquids, or formed above the immiscible liquids, will be the sum, is given as the sum of what? Of vapor pressure of the individual solvents, right? So this is according actuality, immiscible liquids obeys Dalton's laws of partial pressure. Because Dalton's laws of partial pressure, actuality, he said the total pressure in the solutions or in the mixture of the mixed solvents or mixed solutions or mixed gases is the sum of the individual vapor pressure. Okay, so this we'll discuss this property soon. Then the third property is this. We say that when the temperature of the immiscible liquid, when the temperature of immiscible liquid is increased, so when you raise the temperature, is increased, then the vapor pressure formed above the surface of immiscible liquid. As the surface of immiscible liquid will also increase. So this is the third property. We said that when you rise the temperature of the immiscible liquids by either heating or by using any means that you can rise the temperature of it, then what is going to happen is going to affect the vapor pressure formed above the surface of immiscible liquid. So the vapor pressure is going to increase. Right? That's the third property of immiscible liquid. Then the fourth property is going to give us what happens if we change what happens to the immiscible liquids, the relationship between, so it means that the first property explained to us when will the immiscible liquids start boiling? Are there questions? Because when we heat the immiscible liquids, it doesn't start boiling until a certain property has been achieved. And the property is, it means that the immiscible liquids will start boiling when its total vapor pressure is equal to atmospheric pressure. That's the moment when the immiscible liquids start to boil. So that's number 4, the first property. We say that immiscible liquids or immiscible liquids, right, start boiling, okay, start boiling when its total vapor pressure when its total vapor pressure is equal to the atmospheric pressure. When its total vapor pressure formed above the miscible liquid is equal to the atmospheric pressure. That's the moment when the miscible liquid start boiling, right? It's that the moment when the miscible liquid start boiling. So it means that, remember that the standard atmospheric pressure is 101.25 to 325 kilopascals. You can also find this standard atmospheric pressure in your scientific calculator of different functions. For example, in function for the scientific calculator function 991, you can find the constant, and one of the constants that have been provided is at the back of your calculator.